Hello friends, welcome to my channel Study Corner. So today we will discuss about the Coulomb's law. Is Coulomb's law a copy of a Newton's gravitational law or not? So an understanding of a few basic law of the forces of the nature can go a long way towards guiding us through the mysteries of the science. One such a law is electrostatic law of force, was provided by the Coulomb in 1785. And also, the atomic reaction can be explained with the great precision by the Coulomb's law. Coulomb's law. It says as interaction of the charges. Here, we know that if two positive charges are there, then it repels. If two negative charges, then it also repels. And if there is a positive and negative charges, then it attracts. Now see further. If we have two charges, say Q1 and Q2, and the distance between the center of Q1 to center of Q2 is say R, and here the F12 is called the force on the first charge due to 2, and F21 is force on the second charge due to 1. In free space, oppositely charged bodies attract each other, while similarly charged bodies repel with force that varies directly as the magnitude of each charge and inversely as the square of the distance between them. Here, the force being directed along the line joining the charges. Here, as we see, Q2 repels Q1 in any direction, but it is not like that. This Q2 repels Q1 in any direction, as you say, but it is not like that. So Coulomb says that force acts along the line joining the center of the two charges. So it is from Q2 to Q1 in one line joining of two charges, and charge must have a point charge. Coulomb said that charge must have point charge. He also said that the force on the 1 due to 2 and force on 2 due to 1 is opposite in direction, but equal in magnitude, Similarity between the Coulomb's law and Newton's law of gravitation. As we see both equations, then the first one is a famous Newton's gravitation law, and the second one is a Coulomb's law. The first law is given by Sir Isaac Newton, and the second one is given by Charles Augustin de Coulomb. So, if we notice carefully, then we interpret that Mr. Coulomb is copied Sir Isaac Newton's formula. So the question is Mr. Coulomb really copied Sir Newton's idea? Let's see how Coulomb formulated his formula with experiment. So basically, Mr. Coulomb used a device named a torsional balance. Torsional balance, which is invented by him. So he did experimented and derived this Coulomb's law. Therefore, it is not a copy of the Newton's gravitation law. Let's see further. The gravitational force deals between the two masses, which is m1 and m2. Here, the Coulomb's law deals between the two charges. In both the cases, the force is proportional to 1 by r square. And the r is a distance between the two masses in gravitational force and distance between the two charges in Coulomb force. Let's see, the gravitational force is always attractive. In Coulomb's law, the force between the similar charges is repulsive and force between the opposite charges is attractive. In gravitational law, it does not depends on the medium, and the G is called a universal gravitational constant, while In Coulomb's law, the K is a constant of proportionality. It depends on the medium. The gravitational force is very weak while the Coulomb force is very strong. So this is the similarity between the Coulomb's law and Newton's law of gravitation. Let's understand the limitations of the Coulomb's law. Coulomb's law has some limitations. If we take two bodies and it has some charges around this, and also it has some charges around this. So for that we cannot apply Coulomb's law, because two big charges are closer, then we cannot apply. So it is valid for only a point charge. Now what is point charge? Let's understand. So the point charge is the charge which is in a small space. Now let's discuss about more. If we have a big ball which is a metallic and which has a positive charges, suppose it has a positive charges around this, and we take another small ball which is also a positive charges, then it is called a point charge. But can you tell me this one is a point charge or not? So it is also a point charge. If we put very far this ball, then the distance is so far, then we see that it is too small. That's why we also consider this big ball as a point charge. Okay, let's back to the topic. The another limitation is it is applied on charge at a rest. Let's see. Both charges are at a rest, then we apply. If we take two charges, now suppose both charge are at a rest, then we can apply the Coulomb's law. If both charges are in a motion, then we cannot apply the Coulomb's law. Now the third condition is, if one charge in motion and one charge in the rest, then Coulomb's law is valid. So it is not applied only for if both charges are in the motion. So these are the limitations of the Coulomb's law. Thank you for watching.